I'm gonna pause this. I'm gonna show y'all a video. And I'll post you a Cartesian system, right? The American National Standard Robot Industry Association, ANSI IRA report 15.06. Most people just call this the 1506 standard, even though it's 15.06. And we're actually in the 2012 standard. I need to go back and update. Singularity is what? A condition caused by the collinear alignment. So co means at least two, right? You understand that? Like a co-ed. Alignment of two or more robot axes resulting in unpredictable robot motions and velocities. Are we okay? It's most common in robots that utilize a triple row wrist. That's roll, pitch, yaw, axis 4, 5, 6. Everybody okay? Okay. Controlling yaw, pitch, and roll all pass through a common point. Singularities will occur during jogging, whirl jog, tool jog, or user jog. When we're programming, we got two Cartesian programming systems to look at. And this would be when we're trying to do a linear or a circular move. We'll see that when we get into programming. An example of a wrist singularity is when the controlled path moves the robot through which the robot is traveling. It causes axis 4 and 5 to line up. The controller tries to switch from a push to a pull or vice versa. Axis 4 attempts to spin 360 degrees in 0 time. It can't do that, right? You understand. What could happen a lot of times is axis 4 will hit an end stop. When it hits that end stop, it could cause problems with maintaining the load and all kind of problems. Another term for that is what we call a wrist flip. So y'all saw a wrist flip on that video. That's when that axis 4 just does what? It just flips around. Other singularities we have is what we call a shoulder singularity and an elbow singularity. Some industrial robot manufacturers have attempted to sidestep this situation, and what they do is normally just they automatically slow all the motors down. So it lets it flip around, it lets it do everything because that's what it's got to do. But instead of trying to do it in 0 time, it slows everything down. So normally you're jogging a robot, and all of a sudden you got your finger on there. You're not changing the percent speed or anything like that, and that sucker slows down. It means it's probably trying to go through what? Singularity. And it's either going to be using a whirl jog, a tool jog, or a user jog. Those are all Cartesian systems. If you're doing a joint jog, you don't have to worry about singularity because the controller's not trying to figure out which axis to move. It's not trying to figure out which direction to move that axis. Because why? You're controlling that. Another method, some robots just stop. The big fan of robot, if you're running a program and send it through singularity, it'll just stop. Until you figure out how to move those axes around to not make it go through singularity. And of course, this is a big one where it just does what? Reduces the what? Travel speed. So if you ever run a program and it goes through singularity, then most of these robots will just slow it down. So once you do that, all you got to do is figure out how to go the same path by reorienting one of these axes. Does that make sense? So we can change the tilt of the wrist and maintain the orientation of the tool, right? You understand that? There's a lot of ways we can prevent it going through singularity. Is reorient one of the axes that it's going through singularity in. So here's our singularities. Wrist singularity, this would be considered a shoulder singularity, and then the other. elbow. And that video showed all these different singularities. So every one of these robots, when we park them, we're going to park them in singularity. The Kuka is really in singularity. But when we park it, it's laid out like this. So it's got a singularity. It's got this guy right here. In fact, it's actually laid out this way. We don't have to worry about singularity with axis 6 because so all these joints move this direction, right? And it mandates that robot manufacturers shall make the user aware of singularities if they occur while the system is being manually manipulated. Because this could cause some problems. The robot, here you are jogging that robot around, and all of a sudden it wants to flip that whole base around to go from a push to a pull or vice versa. That could cause problems. You know, especially if you're operating the robot in a confined space, like the FANUC welder up there. That sucker is definitely in a confined space. So that sucker couldn't flip that whole base around without colliding with the side of the cell. And I showed y'all the video. That's the video right there. And I'll put the video up on for this lecture. So it's very simple. So this is what we got to worry about. Right now we're up in singularities occur during jogging. We're going to look at world, tool, and user. Of course, you're not going to jog user, but you are going to jog joint. You're going to jog world, and you're going to jog tool, right? When we actually start programming, then we're going to start working about these guys right here. So these bottoms two, this is programming, the top is jogging. Okay? Yeah, those are what we call moves. So when we teach a program, we do what we call move instructions. We tell the robot how we want to move. Well, if we tell the robot to move in linear, what do you think that means? What's linear? And well, not up and down. What's linear? What does linear mean? It means a straight line. It moves in a straight line. So that straight line could be anywhere. It could be straight up and straight down. It could be left and right. It could be at a tilt. Linear means it moves in a straight line. And that's true. So, in CDs, they have what they call linear amplifiers. I don't know if you remember that. And so we'll have to worry about that because there's a lot of calculations that goes on to move in straight. Let's go ahead and group up. What are we going to do? We've got 6 people in the class, which is going to be nice. So they'll put 2 people per robot. Y'all are kind of working at a team while you're practicing. When I come over there and grade you, you are being graded individually. So that means I don't want your team member saying, okay, I want to move that thing to the left. I don't want the other guy to say, well, press this button right there. Right? You understand? That's not the way it works. Right? That would be like having somebody, a backseat driver, when you're taking your driver's test. You'll see SpongeBob. I watch a lot of SpongeBob. I got grandkids. So Patrick put the speaker. He had the big Texas hat that he wore, and Patrick was telling him how to do everything. Because SpongeBob can pass the test, but he can't just do what? SpongeBob can't drive. So that would be like having so you couldn't pass your driver's test if you had somebody sitting in the back seat telling you what to do, right? You understand that? And so that's the same thing true here. So when y'all over there working, and before you get ready, so what you're going to do is you're going to practice a job. You and your teammates are going to practice a job. And then when you feel confident that you're going to know when I say I want that axis 4 to go left or axis 3 to go left or rotate or anything like that, that you know what direction that robot is going to move. because that's very, very important. It's just like you know what direction your car is going to go when you put it into a gear, right? That's very important. You hear about people running into stores and backing into stores and all that kind of stuff all the time, or hitting stuff. And what was their problem? They didn't know what direction their car was going to go. I hope I don't do that someday when I get older. I'm not young right now. Okay, guys, let me. So let's look over this real quick to understand, make sure y'all understand our lab procedures. So this makes it real easy on me and makes it real easy on y'all. Everybody got a copy? Did you get two? Hopefully it'll load. Oh, that's not what I wanted to load. And then these should also be up in Blackboard on the handout section. So food, drinks, and not allowed in the working lab area. Food or dip bottles are not allowed in the classroom or lab at any time. So we don't eat in this classroom, right? Have problems with bugs. Safety glasses must be worn anytime you're on the other side of that wall. You need to have your safety glasses on, except when you come to class. When we're working with robots, you need to do your lab and pencil. I got tired of falling ink a long time ago, especially when you're filling out tables and stuff like that. So I'll use ink to sign off. Before you start, you need to pick up a lab form. We have a clipboard for the class. It's got AUT 212 ROP. That's for robot operation and programming. Your lab forms will be inside here. Your blank lab forms. Should have enough for the whole semester, but if you don't, you need to let me know when they start running out. Huh? Every time you get, for every lab. So what happens is that, of course, I hadn't gave any labs back from last semester. It was really rough. But I'll get those back to you as soon as I can. What we like to do is that I don't have room to store labs. We have to keep record of your grade or how we graded you for 5 years. And then after that, we can shred. Well, instead of us trying to keep up with all these labs, what we do is we keep the lab form, which shows how I marked off what I had. And then what I can do is I can keep a lab form because that's an official record of your grade. And then I can give these labs back to you at the end of the term if you want them. If you don't want them, then what I'll do is I'll shred them. So we don't keep labs anymore. Used to, we tried to keep everything, and we were boxes of boxes a year. We used to have one box for one big old copy paper box for every class we did. Now we have probably one box for the whole department because we don't keep labs. And we don't, all the tests in each class, by the way, are on Blackboard. So they'll be multiple choice. And most of the test information comes out of that document that y'all are supposed to be reading. So there's a pretty good write-up on Singularity in there. So before you start a lab, what you need to do is, we don't have a lab book in here. Eventually we're going to publish the lab book and you'll have to buy it. What we're doing now, believe it or not, it really surprises me how often you find things, people find things in labs that you've been using for a while. So what we want you to do is we give you your labs free because you're our proofreader, right? You understand? So I'll run these labs off for you, and then so you don't have to buy a lab. About the only thing you have to buy for your labs, you need to have safety glasses, and you need to have a ruler that's got the metric system on it, right? Everybody understand that? So I'm going to be saying, okay, we're going to position this 100 millimeters from here, or you're going to put 5 millimeters above that, and it's hard to do that. And we're going to come over there with my ruler, and I'm going to verify these distances. These robots are not about. So if we say 5 millimeters, and that robot is going to be at 5 millimeters, right? You understand? That's what we're trying to do, is prove the repeatability and accuracy of this. So when you get a new lab, let y'all see the lab form. Usually I have one. And y'all can go ahead and keep this one for the first lab. For a while, I made the lab form part of the lab, so you wouldn't have to get the form. But then I realized real quick is that the lab form keeps getting modified, and what I would have to do is I would have to go to all 13 labs and change the lab form. So what we started doing with all our classes is we give the lab form out separately. And so what you do when you start a new lab is you come up here, by the way, this guy here is either going to be out here on the desk, one of these desks, or at the end of one of these rows, or it's going to be up in the cabinet. So normally, if we start the lab, this guy won't be put up in the cabinet, right? You understand? It's just the first one that wants to use it, come up here and just grab it and set it out here on the edge of one of these rows. Are we okay? Okay, this is the wrong lab. They look the same. I'll run them off. This is 212. So I'll have to run those off today. This is the wrong class. Sorry. So another thing on there says make sure you get the lab form that's assigned to your class, right? And this is the lab procedures. Where did I get this at? Okay, here we go. AU2 112 operation and programming. So y'all need to give those back to. And I'll run y'all off today on the printer, and I'll run them off.
The instructions are the same.
Oh, really? Does that say 114? Does that say 116? Fill in the required information at the top of the form. Write your name on the title page of the experiments. These guys don't stay together. I keep the form, you get the lab, right? You understand? And normally it happens almost every semester where somebody don't put their name on the lab, and I count off points, and I have to write it up there. So that's part of the lab procedures. So if you look at the lab form, if you still got it, there's a thing on there that says following instructions, right? You understand? And that would be the procedures that we're going over now. Not having a lab form with the required information filled in will deduct from the lab grade. So I'm over there trying to sign you off, and you ain't got your lab form. You got to come running over and get that. We got 5 people on the list, right? It's like going to get a gun permit, and people want to fill out their form standing at the window. Labs are due at the start of the next class meeting after the instructor signs off the last section of the lab. So you don't have to turn them in. You don't have to turn them in when you finish it, but they're due at the next class. So when I do the last instructor sign off inside that lab, the lab is actually due at the start of the next class. Okay, everybody okay? When your team needs a program signed off or help, one team member must write his or her name on the sign-off sheet that will be located on the top of the clipboard. There'll be a sign-off sheet up here. That's, see. So this sign-off sheet will be on top of the clipboard, right? And what you're going to do is you're going to specify if you need help or if you need a sign-off. Now, when we start the semester, we're real lenient on help, but as we move along, we'll find out that I get more stricter on grading for something that we go over in class or I demonstrate in class and I show you how to do. And then you don't ask questions in class, but then you want to ask questions when I ask you to perform that, right? That makes sense? And that another example would be a driver's test. You go in there and you say, well, what does that yellow light mean? Well, odds are as soon as you say that while you're taking your driver's test, what's it going to do? You're going to fail it, right? You understand that? Of course, while you're out there driving with your whoever's teaching you, they're supposed to do this when you get your learner's permit. So when you got your learner's permit, that's when you're supposed to learn to drive, right? You understand? And like I said, the more we move through this thing, I'll still answer your questions, but after a while, I'm gonna start taking off points because it was something that we discussed in class, and you don't ask the questions in class. Does that make sense? So here's where we're supposed to ask the questions. So when you're getting your learner's permit, that's when you're supposed to ask the question. Whoever's teaching you how to drive, when you take that test, you don't ask questions about what you're supposed to do, right? Hope this is the right one because I still got the other one open up. So what you do is I know what I'm looking for when I go back there, and I don't do two things at the same time. So if you want help, I'll come back and give you help, but then you can't immediately get a sign off for that help, right? You understand? I'll go to the next person on the list. Gives you time to practice or make sure you understand that, and then you put your name back on the list. That makes sense? And then what you'll do is you'll come up and one of your team members will come up and sign this sheet. We got two classes. We'll both use the same sheet, and I go down that sheet. So that means there's none of this grabbing me when I walk by. I'm going to go ahead and walk by you, and I'm going to go over and check that sheet. Everybody understand that? And if there's no names on the sheet, I'll come back to you. But if there's other people on that sheet, then I'm going to go take care of them first. And if you still don't put your name on the sheet and somebody goes up there and puts their name on the sheet, I'm going to take care of them first, right? Because they're following instructions. So you need to put your name on the sheet if you need help or you need anything else, right? But if you're walking by me and I'm walking over there and I know there's no names on the sheet and I say it's okay, there's nobody on the sheet, then I can come over. Everybody okay? Students will take turns programming the robot. Each team member will document the other members of the team on the lab grade form. So you need to learn your team member. Everybody okay? Have the instructor check your progress at each instructor sign-off. Skipping over an instructor sign-off will result in 10-point deduction from the lab grade for each sign-off missed. You may have to go back and repeat the procedure. You might have to go back and later on when we start modifying the program. So we're going to start off by doing basic programming. And then we're going to look at how we edit programs, how we delete programs, how we copy programs. Well, if you make changes and I didn't see it before, then you're going to have to go back and do what? Not only do you lose points, but you're going to have to go back to where I was supposed to sign off. So every time you see that instructor sign off, you need to stop. You don't need to go past that. You need to go ahead and get that thing signed off, right? Everybody okay? And that's what it says. Skipping over instructor sign-offs. Each member must complete a lab grade form. So each one of you are responsible. Everybody gets a lab. Everybody fills in the information on the lab. Everybody comes over here and gets a sign-off. Everybody jogs the robot. Everybody in the team writes these programs, right? You understand? Now, when you're over there with it, you're a team, but when you're getting a sign-off, you're getting a sign-off as an individual. Y'all understand that? So if you have problems on the Teach Panda, then both of y'all can figure it out, but when I come over there and I say, okay, I want you to select World Jog, then you need to know how to do that. Don't, and sometimes that's extremely hard. We have some people that just gotta help. We had a guy who worked out of U.S. Steel, Dennis Ramsey. And, he's retired now, but he was, God bless his soul, he was a foreman, but he couldn't keep it. All you had to say to Dennis was, Dennis, will you come over here and look at these? And Dennis would come over there and he'd be looking, and then he'd get him a chair and he'd slide up there, and then he'd get his meter out, and then he'd get his scope, and we'd go over there and sit at the table and let Dennis do our job for us. And pretty soon Dennis would realize what had happened, and Dennis had a very colorful vocabulary. He'd say a few choice words and he'd leave, and you could do it to him the next day. Dennis was just one of those guys that couldn't stand it. I mean, he just literally couldn't stand it. And we have that people. But be careful over there. Don't get your team. Don't try to give your teammate help when because this should have been figured out when, before I got called back there. Because you're over there practicing. You're supposed to be practicing this stuff. Crib note. So y'all understand that? That'd be trying to use a crib note while you're taking your driver's test. And the doctor and the person giving you the test says, well, put it in drive. And you open up a book on your car and try to figure out how to put it on drive. What would happen? You'd fail. Yeah. Because all that's supposed to be got out of the way while you're practice driving, right? How to turn on the wipers and stuff like that. So if it starts raining and you don't know how to turn on the wipers while you're taking your driver's test, odds are you're going to fail. And I would fail you too. So you're responsible for a lab form. Everybody gets a lab form. Everybody fills out the information in the lab form. I take off points on the lab form, right? You understand that? Everybody okay? And you're working as a team. Does it say this right here? So right now starting off, I'll be responsible for this first step right here where it says place the robot by running the Zero program. You'll have to turn off the air supplies. I'll show you where the air supplies are for y'all's robots. You're going to be responsible for actuating the e-stop on the teach pendant. We leave these robots running anytime. And I guarantee you, if I had a camera in here, somebody would come into this lab and start dicking around with the controls over there. We got a light switch. We got a switch. This used to be automotives. And they've got a switch that kills all the power in the lab. It's on the wall over there. And I would get it home and I couldn't connect to my thing. I'd come in here and the whole power would be off the lab. Somebody went over there and flipped that switch. And it's a momentary contact switch, so you just have to hit it. And so what happened? How did the power go out in this lab and not in the whole building? Well, somebody came in and saw that switch on the wall and did what? Guys, it's built into our genes. Most guys, if they see a switch on the wall, they're going to do what? They're going to try it. If they see a button, they're going to press it. It's just built into our genes. So what I do is I put a piece of paper over that thing, and it hadn't happened since. That's all it took. They can't do what now? They can't see it. And of course, it's no need for us to have that big emergency stop to kill the whole power in a classroom. There's no need for that in this lab. But it was when they had all this equipment in here, right? These lifts and all these tire balancers and all that other kind of stuff. That's what they wanted to do. They wanted to kill everything, right? You understand? So there's one back on that wall. There's one on this wall over here. All it's got is just a piece. It's still there. It's just got a piece of paper hanging. And it's just built. We got over there where they're sitting. If you look at the knobs, people took the knobs off the doors that open up and it's just built into our genes. I've never taught a class that's got knobs in it where some of them hadn't turned up missing. So what you're going to do is we'll park the robots, and we'll show you how to do that. We're going to, the e-stop, y'all know where that's at, right? Okay. You're going to, people don't understand that, and they hit pick it up, and they don't want to go too far. Log off the computers. Make sure you log off your computer in here. That you're going to do that every day. We have people do that. There's the problem with some, and we tried to disable all that, by the way, but most of your web browsers now won't one option you can set is to remember passwords. And we'd come in and people would save their password for Blackboard. That happened over at 200. And you'd bring up Blackboard and it'd log you into their account and see their grades and everything. What we do on this is all these computers in here is on a domain. That's that black computer right there. And what we do is we use a generic login. And it's NETSTU and the password's welcome. It's written on the board up there. It's logged off when you get here. Well, the problem is if you leave your Blackboard account up and somebody comes in and uses that generic, they use that generic password, well, what's going to happen? They're going to see your student suite. If you leave your student suite up, they're going to leave that up. You can check all that. If you log off the computer, it automatically closes everything you got open. So if you had Blackboard open, it'll close it. If you had Student Suite open, it would close it. And you won't have to worry about other people seeing what you got, what's personal, right? I mean, you can check your bank account in here. You know, most of the bank accounts, though, they log off automatically if you don't use it, but I don't know if all of them do that. So you could literally really show these people some personal information just strictly because you didn't do what? You didn't log out your computer. Everybody knows how to log out, right? Click on that little start over there, click log off. Don't shut the computers down, but just choose the log off option. So log off the computers that you use during the class session, place the computers, chairs in the space provided, and slide the keyboard tray. And this is one of my pet things. This is one of the most showed off labs in the whole college. And of course, you can understand why. So we tried to keep it neat. I try, even though I'm having problems. So y'all need to do that before you leave. Just do what? Slide your keyboard tray in, slide your desk under there, log off your computers that you use. And that's about it. So any questions on lab procedures? So here's a blank sign-off sheet. I've ran off some new lab forms for you. I'll go in here and get them. Which robots we're going to use? Yeah, but we're going to only use 3. Okay, so what you need is pick your robot. I'm going to tell you which ones are probably easiest to learn. We'll just have to figure that out. So one of the robots is going to be left open, and in that way, if something happens, it might take a little while, but you can move. And what you're going to find out, and we'll demonstrate this too, is that, you know, when I go over here and jog the robots, I just pick one. So what does that mean? That means they all do the same thing. So you'll find out in robotics is that once you learn one robot fairly well, it makes a real, then you get up and you say, well, that's how they do it. It's just like buying a new car. I get my wife's car. I got in there. She's got a van, a minivan, and it started raining, and I didn't even know how to do what. Turn on the wiper. That was embarrassing. But that's like buying a new car. You know, they all do the same thing, but one might have the gear shift on the column, one of them might have it on the console, one of them might have it up on here, and so you find out where the gear shift's at, right? You understand? You figure out how to run the air conditioner. I have a problem on mine because my wife's air conditioner knob looks exactly like my radio knob. So when I'm trying to turn the volume up on the radio, I turn the air conditioner speed up all the time. And that's what you do. And that's basically, you know, that car does the same thing. It's just that you got to figure out when you move into a new car, you just figure out what. Yeah. They gave me a car to drive up to my training, and I started checking everything out, figured out how I knew how to turn the windshield wipers didn't work on the way. So I carried it back. They gave me another one. But if I didn't try all that stuff out, right, or try to figure out where it's at, and I was driving this car and I didn't know how to turn the windshield wipers on, that would be a big problem. But anyway, guys, let's go ahead and go to lab. Let me bring the lab forms out with the robot, because that's what you'll get if you get out in the field and your company has a robot. They're not going to have a book that tells you how to do everything. They're going to have a manual that comes with the robot. So what we have is we have two places you can access these. And they're very, very big. So if you want to download them to a USB drive, that's fine. In fact, if you want to bring, we have an open network here. We call it public, right? That if you want to bring your laptop in or your tablet in or something like that, and instead of coming over to my rope over here to access these computers, to access these manuals, you could do it over there by the robot. And that's up to you. But these computers are in here for you to use. But if you go to Blackboard, and I think we have all of them up here now. And then of course if we go to Blackboard, did you get logged into Blackboard?
Yes, sir.
I know it's the first day you didn't remember your passwords.
Yeah.
But over here on the left-hand side in the main course menu, in the main menu we have one that says what? Yeah, robot manuals. Now there's tons of manuals. What we got is we just got the manuals that deal with programming the robot. So there's a manual on the ABB, the FANUC, the KUKA. So if we got on the KUKA, we're not going to deal with software versions yet. This explains all the operating system. There's an operating and programming instruction manual. And everything that we need to find should be in this manual somewhere. So introduction, safety, teach pendant, and then of course operation. So this should tell us everything that we need to know in this class. And one of the first things you're going to do before you actually go over to the robot is you're going to figure out how to turn it on. And where are you going to find that at? Somewhere in that manual, right? So understand that. Now all the air supplies are over here on the wall. And they go right down the line. So the KUKA has the orange pipe, and then they go right down the line. And we'll turn that air off every day, because if you leave air pressure on something and you're not using it, eventually it'll start leaking. When you turn the air pressure on, if you ever played around with the air control valve, you don't grab it and turn it on slow, right? You understand? So that prevents a jerk in the system, which blows out air hoses too. So just turn it down slow. Turning it off is no big deal because the lines are already pressurized. It's just that initial when you turn it on, don't turn it on real fast. And I'll show y'all where they're at. We'll go over and turn them all off, and that'll be something that you do when you leave every day. So what you're going to do every day before you leave is today the robots are going to be off, but from now on you will leave the robots on. And basically what you'll do is before you leave is you'll activate the e-stop on the teach pendant, and you'll turn off the air. And you'll do that every day. After a while, once we get into programs, actually doing our basic programming, I'll show y'all how to run what we call the zero program on all these robots. And what that zero program will do is it'll park the robot at its origin. And in that way, if the power fails and we lose the batteries, then we can master the robot, even though the batteries are bad, because the batteries are only used when the robot's turned off. As soon as you turn it on, then it switches over to the power supply. So as long as the power supply is the controller is turned on, the robot is not using those batteries. So it maintains the origin, right? You understand? So what we can do is that we can reorigin a robot without having batteries in it, with power on. It's just that the first time I turn it off, what would happen? Yeah, I would lose everything. I lose the origin. So we're gonna look at that. So if y'all look at the lab, that's the first thing y'all are gonna start doing. You're gonna start doing a little busy work. It's gonna say, okay, find the procedure for how to turn the power on for your robot. So what you need to do now is you need to team up. Who you're gonna team up with, and you need to pick one of the robots. So because you're gonna have to document that every time, right? What robot are you using? And you're not gonna change robots during the semester. Even though you know they do the same thing, just the curve it takes to learn how that robot does it would decrease the number of labs that we can do. I think I told you about the first time we taught the class, right? We barely got through the jogging lab. So we had a real problem program. Are you okay? Questions? Okay.